my name is Nundani Lin.
Hi, my name is Jin Ray. And we're from NUS High School.
And this is our Shell Science Fair entry.
Why do children learn languages faster? How does filial imprinting work?
Well, this can be explained by the term known as critical period. It is the period of heightened neuronal plasticity in early postnatal life. It is a short time frame where our neuronal circuits are more easily molded by sensory experience. Now, a usual critical period will proceed in 3 parts: the pre-critical period, the critical period, and finally adulthood. We see that the maximum plasticity peaks during the critical period. In our project, we have chosen to study specifically on the visual system, as it is one of the simplest models with only 2 inputs into the brain, from the left eye and the right eye.
To study the effects of increased stimuli on brain development, we place yellow fluorescent protein labeled transgenic mice, also known as YFP mice, in 2 simple archetypes. The first is a standard condition environment with a simple shoebox-like setup, with basic supplies of water, food, and a single mother for nursing. In comparison, the enriched environment is a much bigger setup with the same basic necessities but additional toys, and not 1 but 3 mothers for nursing. In the human world, the standard condition compared to the enriched environment is like grassland to Disneyland.
We went about our studies via 2 key components: the neuronal morphology of the YFP mice and their ability to see, also known as visual acuity. By assessing these 2 components, we raise out our hypothesis that the enriched environment can improve the visual acuity of YFP mice.
At the start of our experiment, we first observed each environment in 100-minute periods using an installed camera. We then tallied the amount of time the mums spent with the pups by measuring how long they stayed in this area marked by the red circle. From there, we were able to obtain a graph of the amount of maternal care the pups in each environment received. As can be seen from this graph, the average amount of maternal care received by the pups in the enriched environment is significantly greater than that of the pups in standard conditions. This is the first observation drawn from our studies.
Also, during the observations, we measured the date from birth at which the pups first showed signs of opening their eyes. Our results then show that the pups in the enriched environment opened their eyes at an earlier date compared to the standard conditioned mice. This is in line with prior studies which showed that increased maternal care leads to an enhancement in brain development, enabling the visual system to develop earlier as well, hence leading to an earlier eye-opening date. This will then shift the entire critical period forward, as the enriched environment mice are subject to visual stimuli at an earlier age, thus resulting in an accelerated onset of the critical period, where the neuronal plasticity is heightened.
On postnatal day 27, the mice brains were extracted, perfused, sectioned into thin slices, then finally viewed in a confocal microscope. Here is a 3D stacked image of an isolated neuron in the visual cortex. For comparison's sake, we'll be using the 2D image instead. Here are 2 images from mice placed in the respective environment. A closer look at the neuron at the same distance away from the soma displays significantly greater dendritic extensions in the enriched environment mice. To quantify our findings, we tallied the average spine density of neurons of the mice in both archetypes and see that the EE mice possess about double the spine density compared to the SC mice. The accelerated onset of critical period lets the EE mice have more time to develop their neuronal circuitry. Hence, it is expected and found that the dendritic extensions are increased as well.
After verifying the morphology, we assessed the change in ability of the mice. That would be easy if we could send the mice to an eye doctor. But we can't, so we use an experiment known as the visual water task. In this test, mice have to differentiate between boards with and without lines. The mice are trained to swim to the board with lines as it has a landing platform. The degree of visual acuity is then tested by increasing the frequency of the lines. From this test, we are able to see that at low spatial frequency, where it is easier to differentiate, the EE and SE mice do similarly well. However, at higher spatial frequencies, the EE mice exhibit a slower decrease in visual ability. Furthermore, the spatial frequency at which the testing threshold is reached is significantly greater for the EE mice than the SE mice. Thus, we observe that the increased neuronal connections cause an increase in the visual acuity of the mice. Hence, the mice raised in an enriched environment can see better.
There are both increases in the neuronal morphology and visual ability of the mice due to the environment they are exposed to. Hence, we draw the conclusion that the enriched environment does have benefits for the brain development of the YFP mice, leading to an enhanced visual ability. As most lab-based experiments do, we would also like to propose future directions and possible applications from mice to humans. By taking the benefits of exposure to the enriched environment during the critical period, there can be improvements made to early childhood education, such as making preschools mandatory. Another possible aspect is to promote early detection of certain neurodegenerative diseases, such as autism, to possibly use the enriched environment as a treatment.